Today we're going to do lesson 10.2 and 10.3, which they both deal with multiplying polynomials. When we multiply polynomials, we use the pattern that we like to call FOIL. And each letter in FOIL stands for the method in which we multiply these two binomials. Now, if you remember in 10.1, we recognized what a monomial, binomial, trinomial, and polynomial are. A binomial means that there are two terms in the expression. So right here I have 1 and 2. In this one I have 1 and 2. So I know I'm multiplying two binomials, okay? The pattern that I'm going to use, like I just said, is called FOIL. Each of these letters stand for a different step. The first letter is F, and it stands for first. Then you have O, which stands for outer, I for inner, and L for last. What that means is I'm going to look at these binomials, okay? And I can recognize which terms are first, outside, inside, and last, and those are the ones I'm going to multiply together. Okay, so the first terms. I'm going to look at each binomial, and I'm going to circle the first term in each binomial, which is x and x. So I'm going to multiply those together. X times x is x squared. Make sure that you're not writing 2x, because x times x is not 2x. X times x is x squared. Okay? The next step is outer. Okay? The outer terms of this polynomial. This term is on the outside, and this term is on the outside. X times 3 is 3x. And I put a plus there because I know that this 3 is a positive. Okay? Next step is inner. So I'm going to look for the inner term. So if I just did the outer, then these have to be the two terms that are on the inside. So I do positive 2x. And finally, the last terms in each expression. 2 and 3. And 2 times 3 is positive 6. Now what I want to do in order to simplify is I just need to combine like terms. So I'm going to look. Does anybody see like terms here? Zinko, what are they? 3x and 2x. Very good. So I know that to combine them, I can just add the numbers together. 3 plus 2 is 5. And I keep the like term, which is x. Now I notice x squared does not have a like term. So I'm going to write x squared. And I forgot, I got to put this plus sign right here in front of 5 because it's positive. And then also, 6 does not have a like term. So I'm just going to rewrite 6. This is going to be my final answer. Because there's no other like terms, I realize it's written in standard form because standard form says the largest term with the term with the largest exponent has to come first, and then it decreases from there. So my answer would be x squared plus 5x plus 6. That's how you use FOIL, okay? So remember, first, outer, inner, last. That's the order in which you would multiply two binomials. So this next example, we're going to use FOIL to solve 4 different expressions. Again, I'm going to circle so you can see. You don't have to circle on your paper, but the first terms, because I know F, it means first. So x times x is x squared. Next, I have outside. The outside were x, and let's look at this right here. -4. That negative sign in front of the 4 is important because x times -4 is -4x. Not everything is going to be a plus when we use FOIL. It all depends on the sign. Then we have inside. Inside is positive 2 and x, which is going to be plus 2x. And finally, we have last, which is positive 2 and -4. Positive 2 and -4 is -8x. Okay? So let's combine like terms, which are what, Jake?
Why did you say 8x?
I didn't mean to. I meant negative 8.
Okay,
Okay, what are the like terms?
to the middle, and negative x and 2x.
Exactly, negative 4x and positive 2x. So now I have negative 4 plus 2 is negative 2x, sorry. And then the term that needs to come first is x squared. And lastly, negative 8. Okay? Now, the next one that I have, okay, looks a little bit different. What this squared right here on the outside means is not that I would write x squared plus 1 squared. That's not what that means, okay? What that means is that x plus 1 has to be written twice. So I'm going to rewrite this x plus 1 times x plus 1. That's all that squared means, okay? It doesn't mean anything different. So now I look and I say, oh, okay, FOIL. So first terms are x and x, which is going to be x squared. Outside terms, x and positive 1, which get 1x. Inside terms, 1 and x, which is 1x. And last terms, 1 times 1, which is 2. 1x plus 1x is 2x. It's a positive. And I just write my first and last terms. And this would be my final answer. All right, let's do the next one. Again, I need to FOIL this. So I start with my first terms. X times x is x squared. Outside, 2 times x is 2x. Inside, negative 2x. And last, negative 4. Now let's look what happened, okay? These two terms right here in the middle are my like terms. Positive 2 and negative 2. When I add positive 2 plus negative 2, I get 0. Therefore, these two terms cancel out. I don't need to write 0x. Anytime they cancel out and give me 0, I can just not write it. So therefore, all I have left is x squared minus 4. And that would be my final answer there. Okay? Also, all right, you can write 0x there, but you don't have to, all right? I would not write it there if I were you. Just a waste of time, space, anyways, all right? And lastly, this time we actually have a number in front of one of the x's, which again, it's not going to make anything any different. So let's do the the first terms. 2x times x is 2x squared. 2x times 2 is 4x. 1 times x is 1x. And last terms, 1 times 2 is 2. Combine like terms, I have 2x squared plus 5x plus 2. This is my final answer. Again, remember, you need to make sure and write this in standard form if it's not already. Now, I want to say one more thing before we move on. Let's think about this. The word FOIL has 4 letters in it. F-O-I-L. When we multiply two binomials, okay, let's take this first problem, for instance. We have 1, 2, 3, 4. I have a total of 4 terms, and there is a total of 4 letters in FOIL. That is not a coincidence, okay? That is when you can use FOIL, is when you have 4 different terms. If you have over 4 terms, you cannot use FOIL. If you have under 4 terms, you cannot use FOIL, okay? How many terms does it have when we write it out?
Oh, okay, so it doesn't...
Okay? So let's move on. Now let's look here. Count that. How many terms do we have in these problems? 5. So I realize right off the bat, FOIL is not going to work. So we're going to use another method called the distributive property. We've already learned distributive property this year. Distributive property means Whatever is on the outside has to be multiplied by everything on the inside. Whatever is on the outside has to be multiplied by everything on the inside. Well, let's look right here. I've got two different terms on the outside. It's not going to change anything. Still, I'm going to multiply x by everything inside parentheses, but then I'm not going to be able to stop there because I also have a negative 2 that needs to be multiplied by everything in parentheses. Okay? So, let's go ahead and start that. X times 5 is 5x. X times 3x is 3x squared. X times negative x squared is negative x to the third. And what you do with this is you count how many x's I have. I have 2 here and 1 here. That's why my new exponent is 3. That's how you multiply when you're doing variables. Okay? Now let's do the negative 2 because I'm not done. Negative 2 times 5 is negative 10. Negative 2 times 3x is negative 6x. Negative 2 times negative x squared is going to be positive 2x squared. What I want to do now is I've got to combine like terms and make sure it's in standard form. So in order to make sure it's in standard form, what I'm going to do is I'm actually going to go ahead and look for my largest term. And I know my largest term has everything to do with the exponent, nothing to do with the coefficient. If you remember, the coefficient is the number in front of the variable. The exponent is the smaller number behind the variable. Okay, so I'm looking for my largest exponent. See right here, negative x to the third power. Does negative x to the third power have any like terms at all? No, none. There are no other x to the third power. So I'm just going to write negative x to the third power. Okay? Next, I'm going to look for my second largest term, which is x squared. So I have a 3x squared here and a 2x squared. These are like terms, so I add them together. 3 plus 2 is 5, and I keep the like term, which is x squared. And I like to cross these out once I'm done with them, just so I know that I've taken care of it. Okay, let's look for the next one, which is 5x and negative 6x. Don't forget that sign there. It is a part of the 6x, okay? 5 minus 6x is negative 1x. Cross it out because I'm done. And lastly, I've got negative 10. There is no like term with negative 10, so I'm just going to write it here on the back. Now, the reason why I started with my largest term, because look at my answer. Is my answer in standard form? Yes, it is, because I have x to the third, x squared, x, and then a number without a variable. So I don't even have to worry about rewriting it in standard form. Okay? That's exactly how you do distributive property. All right, so let's do the next one. Okay, I've got to distribute this x to everything. So x times x squared is x to the third power. X times 3x is 3x squared. X times negative 2 is negative 2x. All right, now I need to do the positive 1. 1 times x squared is 1x squared. 1 times 3x is 3x. And 1 times negative 2 is negative 2. All right, let's start with finding our largest term, and then I will combine like terms from there. My largest term is going to be x to the third power, my largest exponent. I realize it does not have any like terms, so I'm going to write that first. My next term is going to be 3x squared and 1x squared. Add those together to get 4x squared. My next term is going to be negative 2x and 3x, which is going to give me 1x. And lastly, my last term is going to be negative 2. Negative 2 does not have a like term, so it just stays on the end by itself. Okay? Let's do this last problem. 2x times 2x squared is going to be 4, because 2 times 2 is 4. Then count up the number of x's I have 3. 2x times x is positive 2x squared. 2x times negative 3 is negative 6x. Okay? Negative 1 times negative 2x, negative 1 times 2x is negative 2x squared. Negative 1 times x is negative 1x. And negative 1 times negative 3 is positive 3. Start with my largest term, 4x to the third. And it does not have any like terms, so I'm just going to write it. My next term are 2x squared and negative 2x squared. What happens when you add those together?
0.
They get 0. They cancel out. Do I need to write 0x squared? No. Just skip it. Go on to your next thing. Okay, my next thing is going to be negative 6x, negative 1x, which is negative 7x. And lastly, my last term is going to be 3. So I have plus 3. And this would be my final answer. Okay, that is the end of lesson 10.2 and 10.3.